Okay, so this should be the last part of the European Commission report on guidance for climate and water adaptation. Scenarios, oops, let me get the pointer up. Scenarios and models for impact assessment and water resource management. We always need scenarios for impacts, estimating future risks, and do adaptations in an uncertain world. Scenarios and models are tools that help to incorporate uncertainty about what will happen in the future into planning. As a simplification, one could say that scenarios are used to create alternative images of how the future might unfold, while models are used to provide information on these possible future. Models have all kinds of issues, biases, uncertainties, internal variability, scenario uncertainties, but nonetheless we need to keep making choices and make decisions. Models are needed to work on a spatial scale fine enough to allow assessment of the possible future impacts in a river basin. Such models need observational data on that scale to be able to calibrate and to run the models and to evaluate the results. So often you have global climate models at some relatively coarse resolution being run. You are taking future projections of climate from that and forcing a hydrologic model or a river basin model of some sort at a much higher resolution. So there is always cascades of errors and uncertainties one has to track. Riparian countries should develop common scenarios and models to develop a joint understanding of the effects of climate change. Common scenario development also permits a more rational use of limited finance resources available. This is very critical. You have to make choices, you have to face uncertainties, and you are dealing with limited resources. So you have to have a flexible mechanism to correct course along the way if you made a wrong choice. Not always possible, but this is the planning and strategy that should work. Overview of the process towards adaptation strategy here, like complicated but feedbacks and flow-throughs. So you have observed hydrometeorological data and observed hydrological data. So you are feeding them, or it's also getting demographic and socioeconomic scenarios there. I can do it. Into climate models could be general circulation models or regional circulation, global climate models, regional climate models. Usually GCM is general circulation model, but you get the idea. These can also be called Earth system models and regional Earth system models. You develop climate scenarios and feed them to hydrological models, blend them with hydrological data to do hydrological projections for water resources, basis for vulnerability analysis and adaptation strategy, which is also getting input from this side here, multi-stakeholder involvement, demographic and socioeconomic scenarios, which are also taking feedback from climate models here, which are also feeding to water use and other policy frameworks and resource management into hydrologic models. They are interacting with water demand and also feeding into vulnerability and adaptation assessments. Okay. Dynamic downscaling, I won't go into the details. I have a whole course on climate modeling where we look at this. So global climate models are coming at a coarse resolution. Atmosphere only models have slightly higher resolution. They are cheaper to run. Regional climate models tend to be higher further because computational cost is greatly reduced, and you do downscaling basically because you want to resolve regional processes better. So then you have hydrology, vegetation, topography, soil, and so on better represented, either using this forcing into another hydrological model like SWOT or the community climate land model, and so on and so forth. Regional land use change, socioeconomic changes, and adaptive responses with regional coupling or forced model. I won't go into the details, but you can look up my modeling course. Depends on whether the ocean and atmosphere are talking to each other, or the ocean is considered moving slowly and is coming in only as a sea surface temperature that's forcing the atmosphere, and so on and so forth. Okay. Vulnerability assessment for water management. Current and future vulnerability assessments are needed for effective adaptation. We have already discussed this. Vulnerability to current conditions can in general be assessed on the basis of information that's currently available, while assessments of future vulnerability require more sophisticated modeling. We discussed before that present risks may be a good guidance for most adaptation implementation strategies and so on, with flexibility left for adjusting to future risks, which are quite uncertain, so you have to be careful. The relevant stakeholders should be involved in the vulnerability assessment to improve its quality and in the development of adaptation measures to enable successful implementation. In the transboundary context, vulnerability assessments should be developed with the participation of all riparian countries to create a common understanding of the vulnerabilities in the whole region. Okay, adaptation strategies and measures. Repeating some points, adaptation strategies and measures should be based on the results of vulnerability assessments as well as on the development objectives, stakeholder considerations, and the resources available. Okay, so development objectives, especially for the global south, have to be synergistic with any other international commitments they have to make. If little or no information is available for structured vulnerability assessments, adaptation should be based on available general information combined with expert and local knowledge. So IMF, World Bank, and others offer some guidance here, but obviously it's a challenge. Effective adaptation strategies are a mix of structural and non-structural regulatory and economic instruments and education and awareness raising measures to tackle short, medium, and long-term impacts of climate change in each sector. Given the uncertainty associated with climate change, win-win, no-regret, and low-regret measures should be chosen as a priority. So you do things that will not harm or will not be maladaptations or waste of money. When possible, that's what you want to do. There is a need to adopt a cross-sectoral approach when formulating and evaluating options. In this respect, C is a useful tool. So I always knew I would forget this. C is strategic environmental assessment. In transboundary basins, cooperation between all riparian countries is needed to design effective strategies. This is easier said than done. There are water conflicts all over the place. Mexico, US, India, Pakistan, and so on and so forth. Here is a box, making water management measures climate resilient. This is a good, nice table, but a lot of text. So, first step, let's say following steps should be undertaken to arrive at climate resilient measures for water management. First step is to assess the vulnerability of the measure regarding climate change, i.e., its sensitivity against anticipated climate change impacts such as changes in precipitation patterns and amount, increasing temperatures, etc. Second step, if the sensitivity is medium or high, the possibility of adjusting the measure to react to expected climate change impacts has to be tested, and the implications this would have on the sensitivity and the costs of the measure in question. I'm not reading the entire text, as you can see. Thirdly, if the vulnerability of a measure with respect to its intended effectiveness is high, it's necessary to check whether this vulnerability affects the overall benefit of the measure. So you have choices made which can exacerbate the vulnerability, but effectiveness can be high overall. So you have to do the cost-benefit analysis of enhanced vulnerability versus overall effectiveness of the measure. Because of often limited knowledge and a certain level of uncertainty concerning the impacts of climate change on the water bodies, the best option is to choose only the measures that can cope with a range of future climate conditions and are sufficiently adaptive to these. So you want to have a what-if scenario set up so that you are doing things with care, so that there are recourses in case there is a maladaptation or you have miscalculated the risk or climate impact of the future. Okay, so water management measures also have to be assessed against the following aspects: compatibility with other adaptation actions. Will the measure enhance or weaken the adaptive capacity of the river basin as a whole, assessment of the potential contribution of the measure to future climate change. Will the measure have impacts on, for example, greenhouse gas emissions? How much energy is needed for the measure, and are there alternative, more energy efficient measures? Coming closer to the end, criteria and indicators for appraisal of adaptation actions. Effectiveness of adaptation has to be done with adaptation function, robustness to uncertainties, and flexibility. So you have typical questions to be asked like, does the measure provide adaptation in terms of reducing impacts, reducing exposure, enhancing resilience, or enhancing opportunity? Can adjustments be made later if conditions change again and if changes are different from those expected today? This is quite a tricky thing. Side effects have to be monitored. You have to have no regret kind of scenarios. Does the measure contribute to more sustainable water management and bring benefits in terms of also alleviating already existing problems? So there is no downside to these investments. Win-win or win-lose. Does the measure entail side benefits for other social, environmental, or economic objectives? For example, does it contribute to closing the gap between water availability and demand? So co-benefits are always very important, or at least have no co-losses, right? Spillover effects. Does the measure affect other sectors or agents in terms of their adaptive capacity? Okay. Efficiency, costs, and benefits. So we discussed this in great extent, has to be low regret as an indicator. Are the benefits the measure will bring high relative to the costs? We discussed many tricky things here because benefits accumulate over time and there is discounting involved, and you are often investing in the benefits of posterity. So social values, cultural norms, resources available, and so on affect these cost-benefit analysis, because non-market goods have to be accounted for in the benefits as well. Framework conditions for decision making, equity and legitimacy, feasibility of implementation. So we have to track barriers to implementation that could be technical, social, institutional, knowledge, etc. Alternatives that are available. So are there alternatives to the envisaged adaptation measure that would, for example, be less costly, would have fewer negative side effects? And priority and urgency. How do we determine the priority and urgency? How severe are the climate impacts the adaptation measures would address? Okay. We'll close out with financial matters. The private sector typically engages in adaptation in cases where it can directly benefit from its investments. We talked very early on in the World Bank report about helping firms and people adapt, which was a critical part of the overall adaptation principle. Governments should complement the private sector contribution to adaptation to ensure that adaptation is funded up to the socially desirable level. We had talked about acceptable losses and unacceptable losses and so on, risks. This can be achieved by setting policies and putting in place an appropriate regulatory framework to help markets stimulate adaptation. Governments should consider reallocating water to achieve greater efficiency while taking into account equity considerations through legal provisions based on customary norms. So how the society values equity and so on matter in these cases in terms of stakeholder engagement, agency, voices heard in setting legal frameworks, and so on. We discussed this as well. So we're talking overall adaptation as well as specific context for water. In a transboundary context, costs and or benefits can be shared according to economic principles of efficiency, although this is not always desirable. So putting value market considerations can sacrifice equity, protecting the vulnerable, and so on. Insurance and reinsurance also have important role to play in adaptation to climate change, which is always true, and they are doing a lot of work on their own in terms of how they hedge their bets or how they underwrite risks, what their exposures are to default rates, and so on. Evaluation of adaptation strategies. Evaluation is needed to determine the relevance, efficiency, and effectiveness and impact of the adaptation strategies in light of their objectives. Evaluation should be carried out during implementation, at the completion of the project, and some years after the completion. Monitoring, evaluation, and reporting is always very critical for any adaptation intervention. Evaluation should be based on predefined quantitative or qualitative performance indicators which show the progress towards a specific objective. If aims of an adaptation strategy have not been reached, the root causes of both the success and failure should be analyzed through more detailed evaluation. Learning by doing is very important since it helps practitioners to make mid-course corrections, be flexible in the adaptation implementation. Pilot projects should be carried out to test the chosen strategy. All these are good principles and strategies, but financial resources are always going to determine what actually happens. Participatory evaluation can add value and enhance feasibility and acceptance. So people's engagement, stakeholder engagement, co-development of solutions are always critical to make sure that adaptation is implemented fully and is effective as intended. Okay, so this concludes the European Commission report on guidance for adaptation to climate change and in the water sector. There are other sectoral considerations we looked at as well. Okay, so we'll come back and look at just one more short report on adaptation for water sanitation and wastewater treatment, and then conclude this section on adaptation for the water sector. Okay.